Hi guys. All right, so let's move on to student activity sheet 4. So you should be on SAS 4. So here's the digital copy. Or if you're in your workbooks, let's see what page we should be on. We should be on page 559. In Agile Mind, make sure you're going to My Courses, topic 15, Exploring, and we're on the changes to the parent function. All right. So we have a local radio station is sponsoring a basketball shooting contest during halftime at the upcoming varsity basketball game. Brian and Jerry decide to enter the contest for fun and they begin practicing different free throw shots. Play the animation to see each one shoot the basketball. What do you notice about the shapes of the paths that the basketball shots create? So if you click on each player and you click shoot, you see Brian's free throw. And then you can also see Jerry's. For question number 1 on SAS 4, what type of shape is each path? Each path is a parabola. So make sure you fill that in for question number 1. And then if we go back to slide 2, it gives you a little description about the fact that each shot follows a parabolic path. So far we've looked at what A does, right, and what C does. So we talked about how A stretches or compresses our parabola, and C shifts our parabola up or down the y-axis. So how can we use what we know already to figure out the function rules for each of the basketball shots? So if we look at Brian's shot first, let's click on Brian. Your job is to match the orange dotted parabola because that's the path that Brian's basketball actually took. So we need to turn our green regular parabola, which is y equals x squared, into this upside down parabola to match Brian's shot. So just like we talked about the other day, when A is negative, your parabola is going to be upside down, right? We also notice that the vertex went up instead of starting at 0, 0. Now it's up here around 13. But my green parabola still doesn't match the orange parabola just yet. So I got to make it narrower. So I need to increase the value of A. Or in this case, since it's in the negatives, I need to decrease it. All right. And then once you get it perfect, you can see the equation. Y equals negative 2x squared plus 13. So that's what we want to write for number 2. What function rule represents Brian's shot? Y equals negative 2x squared. It was upside down. It was narrower. And plus 13 moved it up the y-axis. So what is the highest point on Brian's graph? And how does it connect to the function rule you found? Well, if I go back to look at my parabola, my highest point is our vertex, right? That's a maximum. So the highest point is 13. So our y-intercept is 0, 13. And that's our highest point because k, right, our number here, shifted it up 13 spaces. So we can say it went up 13 units. So same thing for number 3. Let's look at Jerry's shot. So if I go back and I click on Jerry, Again, we have to match the green parabola, which is our parent function, y equals x squared, and we need it to match the orange parabola for Jerry's shot. So we got to go upside down again. So I need to make a negative. It also got shifted up the y-axis. Looks like it's around 11. And I need to make it a little bit narrower. And there you go. So y equals negative 1x squared plus 11. So y equals negative 1x squared, or negative x squared, plus 11. So same idea here. The highest point on Jerry's graph is the vertex right here. That's our maximum, which is at 11. So our y-intercept is 0, 11. And that's the value of our vertex because it got shifted up 11 units from 0, 0. Okay, so most of this so far hopefully should be familiar or sound familiar. So the next thing we want to do is sketch a graph of y equals 3x squared plus 2. So if we go to the next slide, all right, if you read through this animation, this kind of talks about the idea of stretching and compressing. So if you click play, what they're trying to show you here is that from our normal parent function, which is y equals x squared, from the vertex to the next point, which is 1 over on the x-axis, the horizontal length is 1 and the vertical length is 1. Okay, so if you were making a table, right, your first point would have been the vertex, which is 0, 0, and your next point on the parabola is 1, 1. Your next perfect point, I should say, right? So if you go to panel 2 and you click play, even though the blue parabola is upside down and it got shifted up the y-axis, it still has the same it's the same width. Like it didn't get narrower, it didn't get wider. So from the vertex to the next perfect point, the horizontal length is 1 and the vertical length is 1. So this tells you that there was no stretch or compression. The only thing that happened was that it got flipped upside down and it got moved up the y-axis. Well, now if we take a look at this next animation, they're trying to show you that Brian's parabola was a vertical stretch because instead of having a horizontal and vertical length of 1 and 1, here to get from Brian's vertex to the next point, which is 1 over, you have a vertical length of 2, right? So think about slope. Something with a slope of 2 over 1 is steeper than something with a slope of 1 over 1. So that's why Brian's parabola is also a vertical stretch. And we say it's a vertical stretch by a factor of 2. Okay, so that's where our A value went from a 1 to a 2, right? And the negative just means it's going to be upside down, but the 2 stretches it. So if you go to panel 4, they want you to explore different values of A and K and see what happens to the triangle as you move A up and down, right? So the higher you go, the steeper, the narrower your parabola gets. So again, that idea of slope, you're getting steeper. Same thing when you go into the negatives. The more negative you go, the narrower and the steeper your parabola looks. if you have a value less than 1, right? So if you go back to 1 and you decrease it, you're now compressing your parabola. So that triangle is getting shorter. So your parabola is getting wider. So now you try this one. It says you can go to Desmos. So if you want to click on the link, it'll take you to Desmos. But on Agile Minds, try to do it, without actually typing anything in. So right now we know that it's got to get shifted up 2 units. So the first thing I would do is I would click on the dot icon, and instead of it starting at 0, 0, I'm going to go up 2 units. That's where my vertex should be, right? And then the other thing that's going to happen is there should be a stretch because A is now 3. So instead of my triangle being a 1 and 1, I want it to be a 1, but I want to go up 3 because it's going to be steeper, right? So I want to make sure my next dot is up here. And if I reflect that over the y-axis, I'm going to take the pen and I'm going to connect my dots. And then if you click check, you should see it's not bad, right? So again, you could try it on here, you could try it on Desmos, but try to do it without actually looking at Desmos first. And then you could always check your answer on Desmos later on. All right, same thing on the next slide. This is question number 4 on the worksheet. They want us to sketch 2x squared plus 3. But instead of sketching, we just got to drag the dots. So I know the plus 3 means I'm going to move my vertex up the y-axis 3 spaces. So I'm going to take my vertex and I'm going to go up to 3. And then I also know that if A is 2, it's going to stretch my parabola. So I want to move my second dot. Now, if I kept it like this would be a 1 by 1 triangle, right? So I want to get steeper. Because remember, I want to go over 1 and up 2 units. And then if you click submit answer, it'll tell you great work. All right, so one more like that. Now they want us to sketch y equals negative 2x squared plus 3. So same thing here. I want to move my vertex up 3 spaces. I still want to stretch it by a factor of 2, but I want to be upside down. So I want to go over 1 and down 2. So my dot's already in the spot it needs to be. And you're going to click submit answer. All right. So again, all of these you could either do here and take a screenshot, or you can do on Desmos and take a screenshot, but that's what you're doing for 3, 4, and 5. Okay. So now on the next slide for number 6, you want to try to fill in this puzzle based on all these parameters we've been talking about. All right. So if we're thinking about y equals ax squared plus k. All right, let's talk about a first. So when this value is positive, our parabola is going to open upward, right? It's going to look like a regular U shape. Okay, but when a is negative, that's when it's going to be reflected over the x-axis. So our parabola is going to open downward. The next two are talking about the absolute value of A. So as the absolute value of A increases, right? So instead of being 1, what happens if we increase it to 2 or 3 or 4? Our parabola is going to stretch, right? It gets narrower, it gets skinnier. When the absolute value of A decreases, right, it's going to get compressed. And remember, they're using the absolute value bars because that happens when it's ups, when it opens upward normally, and the same thing happens when it opens downward. So think about it, guys. If we have y equals 3x squared and y equals negative 3x squared, they both have the same absolute value, right? The absolute value of 3 is 3. The absolute value of negative 3 is also 3. So they both get stretched by a factor of 3. The only difference is positive 3 is upward, the negative 3 would open downward. Okay? And then k, what happens when k increases? So if you see plus a number, it's going to shift up the y-axis. If it says minus k, it's going to shift down the y-axis. And then the vertex of the parabola has coordinates. Whenever you are on the y-axis, it's always going to be 0, comma, whatever k is. All right, so that's everything that you should fill in for number 6, A through G. All right, and the last thing we're going to go over, this is for question number 7. It's another little puzzle. You're going to try to match the picture with the equation. So use everything that we've been talking about so far with A and K. And let's see if we can match our graphs. So if we look at this first graph, right, we can't really see too much of it. We can only see the bottom, but we know that it's opening upward. We also know it looks a little bit wider than usual. All right, so it opens upward, it's a little bit wider, and it also got shifted up the y-axis, right? So instead of 0, 0, it's starting way up here. So I always like to think of the k value first, right? So since k was moved up, I know I need to have a plus at the end of my equation. So it can't be minus 6. So that eliminates those 4 choices. I also can see that it's opening upward, right? So my a value can't be negative. So that eliminates these 2 choices. So now I'm down to 6x squared plus 6 or 1/6 x squared plus 6, right? So since it's wider, remember, that means that it's a compression. So that's usually a number less than 1. So any fractions or decimals less than 1 is going to make your parabola wider. All right. Same idea for the next picture. But now my parabola got shifted down the y-axis. So I know my my k value has to be a minus. So I'm going to delete everything that has a plus. It also is upside down. So I know my a value has to be negative. So that's going to eliminate these 2, right? And again, since it's a wider version, it's a compression. So your a value has to be a fraction or a decimal less than 1. All right. And then the last 2, it's got shifted down the y-axis. So I know I need a minus at the end. it opens upward, and it's narrow. Okay, so if you put all those pieces together, it's got to be a positive A, a number greater than 1 because it's a vertical stretch, and it got shifted down 6 units. This one got shifted up, it's upside down, and it's also narrow. All right, so those are your answers for number 7. That's the end of SAS 4. All right, so let me know if you guys have any questions. Fill in that worksheet, submit your answers, and I will talk to you later.